Hello and welcome to the law of cosines. This is the second trigonometric law that's used for non-right triangles. So again, this is the big distinction that makes it so different from just using sines, cosines, tangents. When you're dealing with non-right triangles, you can either use the law of sines, which doesn't always work for you, or you can use the law of cosines. And I'm just going to illustrate why we have the law of cosines. It's a little more complicated in some respects than the law of sines. Let me just show you why we have to have it. Suppose you had a triangle and you knew this side here, or this angle here, and we're going to label the rest of it here. Suppose you knew this angle A, but you didn't know side A. You knew side B and you knew side C. So, I'm just going to check off what information you know. If you try setting this up with the law of sines, it won't work. And let me just show you why. If I said, okay, sine of angle A over A, whoops, I don't know this one. So I'm just going to highlight the ones I don't know. So that's an incomplete ratio. Well, if I look at any of my other ratios, how about sine of angle B over B? Well, I don't know angle B. So that's incomplete. So I can't use these two ratios and cross multiply and divide. I don't have 3 out of the 4 ingredients. I only have 2. So it won't work. And if I tried going to angle C and side C again, well, I don't know angle C. So this is also going to be unknown. So no matter which two ratios you try to combine and put together, you only ever have 2 of the 4 ingredients. Not enough to solve. So in a situation like this, where you have an angle, you know the angle and the 2 adjacent sides, but you don't know anything else. You don't know these 2 angles or this side here. You have to go to something else. And that something else is the law of cosines. So let me show you how the law of cosines would look in this case. It's probably going to be a bit muddling for you, but you have to be very determined with the law of cosines. You'll find after the first couple of examples that you work through, it actually starts to click and it becomes quite easy after you've done a few. And the reason it becomes easy is because it's always repeating. It's basically always the same setup. So let me show you what that setup is. And this is what works for me. I'm looking for, in this case, let's say I want to find side A. So opposite the angle that I know is the thing I'm looking for. So it starts off like this. That unknown side squared equals. Now, from now on, you're only going to use the 3 things that you know. The angle and the 2 adjacent sides. And it works like this. It equals B squared plus C squared minus 2 times B times C times the cosine of angle A. Now I know if you've never seen this before, it looks quite confusing and discombobulating, but in fact, when you see it used in an example, and as you work through it yourself, because of its repetitious nature, it's not too bad. Keep in mind that you're solving for A squared, and so if you wanted to find A, you would have to square root all of this stuff. So you tuck all of this under the radical. Okay? And if you're using a calculator, that means put some brackets around there. So let's get into an example and just show you how it can work. Okay, in the first drawing here I got a nice little non-right triangle, and I kept it labeled pretty much as we've been labeling them all along. And so I'm going to say, I know that that's 7, that's 5, and I'm going to say, well, that's about 80 degrees. And I just want to figure out what I don't know here. In other words, I don't know angle A, I don't know angle C, and I don't know the length of side B. So let's just list these things over here. I'm going to have to figure out B, angle A, and angle C. That's what my answer is going to look like. 3 things. Okay, well, with experience, you'll recognize that, I've got an angle and the 2 adjacent sides. That means I got to go straight to the law of cosines. And so as you work through a lot of trig, you'll be able to recognize when is it a law of sines, when is it a law of cosines quite quickly. This is typically a law of cosines. So I'm going to start off with, the side across from the angle, and that's B. So B squared would equal, and then I have my 2 adjacent sides. And it doesn't matter which one goes in which order. If you like, we'll start off with A. There's A squared plus B, C squared in this case, minus 2 times A times C times the angle between them, which is 80 degrees. And keep in mind, we have to square root this. So I'm just going to go ahead and with the wonders of technology here, I'm going to change this to B and put this all under a square root symbol. And so you should find, if you put that through in your calculator, it turns out to be 9.6. Okay, so there we go, 9.6. Now to figure out angle A or angle C, you don't need to use the law of cosines again. Now we can use the law of sines, which is probably a little more straightforward for us. So let's go ahead and do that. So what we've got now, and I'm just going to put that into the picture, is we know that is 9.6. So I can go, sine of 80 degrees divided by 9.6, that's going to equal, and pick whichever one, let's go with A here, the sine of angle A divided by 5. So I'm going to cross multiply and divide, which means I'm going to go 5 times the sine of 80 and divide that by 9.6. And remember that you haven't solved for angle A, you've solved for the sine of angle A. So once you get this number, you've now got to go sine inverse of that number. And the number that you should have got, I wrote it down here, was 0.513. And that means that when you take the sine inverse of this thing, you should get that to spit out about 30.9 degrees. So now we've actually solved for angle A. So 30.9 degrees. And once we've got angle A, we're laughing because angle C is not going to be any work at all. And let me just show you why. Well, you've got 3 angles in a triangle that have to add up to 180. So all we have to do is go 180 and take away 80, take away angle A. The difference is going to be your remaining angle, and that should turn out to be 69.1 degrees. Okay, now here's a little tip that can help you check your work without going back to the beginning. With any triangle, the longest side is opposite the biggest angle. The shortest side should be opposite the shortest angle. So as a quick way to make sure my work isn't totally crazy, of my angles, and maybe I'll just write them in here. We've got 30.9 there, and we've got a 69.1 here. My longest side is the 9.6, and it's opposite my biggest angle. So that's good. My shortest side is 5, and it's opposite my smallest angle. So that's a quick way to kind of make sure there's nothing really wonky going on. So there's my answer, full marks. Okay, I've got one other example to show you with the law of cosines. One other situation which involves a little bit of algebra, not too bad. And that is if you have this kind of a triangle. And again, we'll just label it nice and straightforward, good old ABC. And we're going to say we know all three sides, but we don't know any angles. Now, it won't take you long to realize you couldn't use the law of sines, because the law of sines requires in each ratio knowing some angles. We don't know any angles. So that means this can only be solved by the law of cosines. And here's how you do it. Let's say we want to figure out angle C. And let's just say that's all the question asks of you. Alright, so you want to get this angle. So we're going to set it up with the law of cosines, which means the opposite side is 5. So 5 squared equals, and we have these two adjacent sides, so we'll go 6 squared plus 7 squared minus 2 times 6 times 7 times the cosine of angle C, which we don't know. Well, now all I have to do is kind of slog through it and isolate cos C. This is the thing that I don't know. All the rest of it's just numbers. So let's move things to the other side. Let's square things out first of all. See what it is we're working with. And here you could even go 2 times 6 times 7. Turns out that's 84 times the cosine of C. And I'm going to keep this kind of boxed in so that it's highlighted. We know that's the thing we want to isolate. I'm going to take away 36. I'm going to take away 49 from both sides. So to get rid of these two, I'm essentially doing this. And so that leaves me on the left side here, negative 60 equals negative 84 times cosine of angle C. To get rid of something you're multiplying, I'm going to divide by negative 84. So both sides get divided by negative 84. That cancels over there. And I've got negative 60 divided by negative 84. Well, I've run out of room, so I'm just going to back up a little bit here. And so in decimal form, that looks like this, 0.7143. And we've now isolated cos C. So now the question is, how do we get angle C? Well, we want to get rid of cos. So we're going to go cos inverse of cos C. And what you do to one side, you have to do to the other side. Cos inverse of 0.7143. Okay, why do we do that? Because cos inverse and cos kill each other off, and that leaves you with angle C. So this becomes just something to do on the calculator. And if you do it correctly, you should get 44.4 degrees. A lot of 4s. Anyway, that being said, I concluded my discussion on the law of cosines. Beautiful stuff. We'll catch you later.